Do you know which technology is used to classify the movie queries? A search for a movie will restore a web page that is arranged into a category such as reviews, trailers, stars, and theater. We can classify these queries using clustering, which divides them into a subclusters or subcategories, creating an hierarchical structure that allows you to analyze a query's outcomes. On that note, welcome to Simplilearn YouTube channel. Today, we are here with a fantastic video on hierarchical clustering using Matlab, which will help you to perform hierarchical clustering on various datasets. Before we begin, are you aiming to get certified as a data analyst and want to build your career in data analytics? In that case, you can check the Data Analyst Certification course by Simplilearn, which will open the doors for the best career opportunities. To find more details about the Data Analyst Certification course, check the link below in the description. It could be an ideal solution to help you build your career in the right direction, as we have a special discount to our YouTube members. To avail that deal, use the coupon code YTBE15. And if you haven't subscribed yet, please subscribe to our Simplilearn YouTube channel and hit the bell icon to never miss an update from us. Before we get started, here is a question for you. Which type of analysis is not done by the Matlab software? Let me know your answer in the comment section below. Just quickly go through the agenda for today's session. First, we will understand what is clustering. Then we will understand what is hierarchical clustering. After that, we will understand the difference between clustering and hierarchical clustering. Then we will understand what are the different types of hierarchical clustering. Followed by, we will see how to use them in the real world. Then we will understand how to implement clustering in Matlab. Followed by, we will learn how to create hierarchical clustering. At last, we will implement both clustering and hierarchical clustering in platform. Let's try to understand what exactly clustering is. Clustering is a technique used to group a similar data points together based on their characteristics or features. In simple words, grouping unlabeled examples is called clustering. Then, what is hierarchical clustering? Well, hierarchical clustering is a method of clustering data points into groups based on their similarities or dissimilarities. In this method, there is a tree-like structure created which is also called as dendrogram, where each data points is represented as a leaf node and the cluster are represented as a branches. The tree is not a single set of cluster, but rather a multi-level hierarchy where the clustering is done one level and joined as a cluster at the next level. We have gotten basic understanding of clustering and hierarchical clustering. Now let's see the difference between clustering and hierarchical clustering. Clustering is a technique that involves in the grouping of set of data points into a cluster based on their similar characteristics. Hierarchical clustering is a specified clustering algorithm that creates a hierarchy of a clusters. Clustering does not create an hierarchy of a cluster. Instead, it is a simple group of data points into a fixed number of clusters. Hierarchical clustering is used in a dendrogram showing the hierarchical relationship between the clusters. Clustering needs the number of clusters to be specified ahead of time. Hierarchical clustering does not require the number of clusters to be determined. Now it's time to understand the types of hierarchical clustering. There are two types of hierarchical clustering: agglomerative and divisive. Agglomerative clustering is a clustering where each object starts its own clusters and it's progressively merged with its nearest neighbor until all objects are in a single cluster. In divisive clustering, all the objects starts in a single clusters and are progressively split into a similar clusters until each object is in own cluster. Moving further, let's know the use of clustering and hierarchical clustering in real world. Clustering and hierarchical clustering are the popular techniques used in various fields of data analysis, pattern recognition, data visualization, and many more. For example, let's first consider image segmentation. Clustering is also used in image processing to separate the image into multiple segments or regions. This is useful for tasks such as object detection, image compression, and image segmentation. And the second usage is medical research. Clustering is used in medical research to analyze the patient data and identify the subgroups of the patients with similar medical conditions. This helps the researchers to identify the risk factors, develop treatment plans, and personalize the treatment for individual patients. And the one more popular usage of clustering is social networking analysis. Hierarchical clustering is also used in social networking analysis to identify the communities or groups of individuals with with a similar interest or behavior. This helps the researchers to understand the social dynamics, identify the key influencers, and analyze the information diffusion. Now let's understand how to create clustering in Matlab. The basic steps to create clustering in Matlab first is to load your data. Load your data into a Matlab using any of the supported file formats such as CSV, MAT, or TXT or any other. The next step is to preprocess your data. Preprocess the data by removing any missing or irrelevant values and normalize your data if required. And the third step is to choose the clustering algorithm. Choose a suitable clustering algorithm based on the characteristics of your data and the objects that you are analyzing. The common clustering algorithms includes KMeans, hierarchical clustering, and many more. And the fourth step is to set a parameter. Set a parameter of a chosen clustering algorithm such as the number of clusters, distance matrix, and the clustering method. And the last step is to perform clustering and visualize the result. Use the clustering functions in the Matlab to perform the clustering on your data and visualize the result of clustering using the plots and the graphs and helps them to interpret the results. Now let's understand how to create hierarchical clustering. The first step is to load your data. You need to load your data into a matrix format where the rows represent the observation and the column represent the variables. And the second step is to choose the distance matrix and the leakage method. Select the distance matrix and the leakage method that suits your data and the analysis that you want to perform. The next is to calculate the distance matrix. Use the pdist functions to calculate the distance matrix between all the observation in your data. The fourth is to create the leakage matrix. Use the leakage functions to create a leakage matrix that defines the hierarchical clustering, the inputs to the functions that are distance matrix and the chosen leakage method. And the last one is to plot the dendrogram. Use the dendrogram functions to visualize the hierarchical clustering as a dendrogram. Now let's implement clustering and hierarchical clustering in the platform. First, let's implement clustering in Matlab. For that, first I'll load a dataset. I'll use a function called load and dataset name. I'm using Fisher Iris dataset. You can see we have means and species, which is of 150 cross 4 double matrix, and species is a 150 cross 1 cell matrix. Now what I'll do, I'll take a variable called data and normalize means into entire column and the second row till the end. Close the bracket, end with a semicolon. Now we have a data of 150 cross 3 double matrix. Now what I'll do, I'll normalize this data. Data is equal to, I'll use a function called normalization or normalize. Within the square brackets, I'll pass the variable called data and with a semicolon. Now, I'll take a variable k and define the number of clusters. As we know, in clustering, we have to define the number of clusters before we perform clustering. Next, we can see we have a variable k which has a 3, as we have defined the number of clusters is 3. Now I'll take one more variable called outputs, and in that I'll define a static set. Static set which will create the statistic operations of a structure. I'll give a 2 variable called display and final, and I'll just close the bracket and end with a semicolon. Now to perform clustering, we are using K-means algorithm for this dataset. To take that, I'll use a 2 variable called index and a C, which is equal to, I'm calling KMeans algorithm using an variable called KMeans, and within the bracket I'll give data K, a clustering element, and then I'll give the distance. After that I'll give the distance, and I'll just also mention the replicates, and I want 5 replicates within the quotes we have to mention, and I want the 5 replicates, and I'll mention it as 5, and then with quotes I'll give the options, and at last I'll call a variable which we have created the static set of operations or structures. We can see, as we have already told, we have 5 replicates, replicate 1, 2, 3, 4, 5, and respective iterations. We have total number of distance between the replicants and the iterations. And we can also see the best total sum of the distances is 94.6833. We also got the best total sum of the distance. Now it's time to visualize this data in the form of graphs. Before that, I'll just clear my screen. Now we will visualize this data. First, I'll call a function called figure. Then, after getting back to the command prompt, I'll just give I'll use a scatter plot. I'll use scatter of data with respect to the first row, and again data with respect to this second row, close, and the size is 10 with respect to IDX, and I want my scatter plot to be filled, and I'll close the semicolon and enter. Now I'll just say hold on, space, hold on, and I'll using plot, I'll also plot C, that is C of entire row comma 1, and same it as C of, at least capital C of entire thing comma second one, and I'll mention all the parameters, markers. Oh shit, sorry, I just forgot to mention the marker size. I'll give it as marker size, and I'll specify it. It should be inside the quotes. Specify the marker size as 15, comma, and I'll just specify the line width should be 3. Close with a semicolon, and using legend function, I'm labeling them as cluster 1, again same, cluster 2, comma, cluster 3, close the brackets, let the CB caps to maintain the uniformity, and then I'll also create the center rods, close the quotes and the comma, mark the location, close the quotes, comma, last end with a semicolon. Oh, I just made a mistake in the spelling of legend. Let's just run it once again. As you can see, we have got this graph. In our dataset, we have three different flowers of different characteristics. One flower is represented as in blue color, one is represented in yellow color, one is represented in purple color. As we can see, the into marks are the clusters that are the similar characteristics that three flowers which has, and cluster 1 is the similar characteristics that the flower 1 has. Like this, you can perform clustering to any different data set that you want using Matlab. Now let's see how to perform hierarchical clustering. First, we'll perform hierarchical clustering by creating our own dataset. Before we move on, I'll just quickly clear my screen and clear all the variables using CLC and clear option. As I said earlier, we will perform hierarchical clustering for two different datasets. First, we will create our own dataset. To create or to load our own dataset, we will take a variable called data, which is equal to rand of 50 cross 5. Rand is a variable which will create a random integers from 50 to 5. As we can see, we have variable data which has 50 cross 5 elements. Now we have to choose the distance matrix and the leakage method. For that, what I will do is I will take a variable named as distance metric, and we will use the famous distance metric, that is Euclidean within the quotient and the semicolon. And for leakage underscore method, use like compete and with the semicolon. Now we have to calculate the distance metric and then will calculate the leakage metric. For first we will calculate the distance metric, that is, again I will use the keyword called distance, which is equal to, we will use the function called pdist. Inside that we'll pass a data, comma, and also we'll pass the distance metric function and end with bracket and semicolon. Now again I will do the same for the leakage metric, that is we will do, again we'll take the keyword variable called linkage and we'll just use a function linkage. Within the bracket we'll pass the distance and the linkage method function and close and the semicolon. As we have you can see we have calculated both linkage and distance matrix. Now at last we will just plot the dendrogram using the function called dendrogram Within that we'll just pass the cage. With the semicolon. You can see we have got the dendrogram. As we discussed, hierarchical clustering forms a tree-like structure which is called dendrogram. We can see this graph looks like a tree and this subgraphs look like its branches. Like this, you can perform hierarchical clustering for your own datasets. Now it's time to see how to perform hierarchical clustering for a dataset or loading the other dataset from Google or Kaggle anywhere. Before that, let me clear all the figures and clear my screen and workspace. To perform hierarchical clustering for loading the dataset, I have already downloaded the dataset called digit.csv and imported using the import option. You can also download any dataset that you want and use the import option to import your dataset, and it will be saved in the file section. First, we'll load the dataset using load digit.csv, close the semicolon. As we can see, we have a variable called digits created with the dataset of 1797 cross 65 matrix. Now we will just calculate the distance using the variable as we used before called distance, which is equals to, we use the function called pdist. Inside that we will pass our data set, that is digits, and call our famous distance calculator, that is Euclidean, using, and just close the brackets and the semicolon and press enter. As you can see, we have a distance variable created here. Next, again the same way, we will calculate the leakage, which is equal to the leakage function. Inside that we will pass the distance, and here we will give the average. Now using the dendrogram, we will just plot the leakage. So just close and end semicolon and just press enter. As you can see, we have got an dendrogram graph. As we know, the hierarchical clustering forms a tree-like structure which is called dendrogram. This is the dendrogram which has been created for dataset. Now getting back to the command prompt, now we will define the cluster number and then plot it using the scatter plot. Before that, I'll just clear my screen, and now I'll give num underscore cluster is equal to 3 and semicolon, enter. Now we have the number of clusters which has been defined. Now we will define the cluster assignments, which is equal to cluster function. Within that, I'll pass the leakage and then the max cluster and the number of clusters that we have defined, and run. Now I have to plot this. For that, I am calling figure function and then scatter plot using scatter scatter of, first one is a cluster assignments versus the num clusters. The size should be of 20 and it should be, I want it should be filled, mention it as filled and end with a semicolon enter. As you can see the graph, we have got our scatter plot as per our cluster assignments and the num cluster, that is the number of clusters we have specified as 3, and we have got a maximum clustering points of our dataset. Like this, you can perform hierarchical clustering and clustering for any desired dataset that you want. With this, we have reached the end of this session. Today, we have learned what is clustering, understood what is hierarchical clustering, what are the real-world uses of clustering and hierarchical clustering. We also learned the steps to implement clustering and hierarchical clustering. At last, we implemented clustering and hierarchical clustering for different datasets. Please like this video and share with your friends. For more such videos, please visit our Simplilearn YouTube channel. For any query regarding this topic, mention it in the comment section. Thank you. Keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.